Hello, everybody. I am honored to be here. You people are awesome. I am humbled also by your talents. So today we're going to try to do something that will not be to the height of all your super graphics performance guru-ness, but will be more about something I know about and I hope I can teach you, which is about achieving flow with the Android platform. So a little bit about me first. So my name is Etienne Caron. I'm an Android fanboy. The reason I'm in contact with the demo scene is I'm a long time attendee, organizer. So I used to organize demo parties in the 90s. So I'm also a demo scene fanboy, which should be written there, but you know. And nowadays what I actually do is I'm an organizer for the GDG Android Montreal. And I'm also part of Google's Dev Expert program for Android since last summer. So the job there for me is to go out and do mentorship with students, startups, and show them about the platform, and come here and talk about it with you guys. All right. Oh, I'm a bit nervous, but that's OK. It's going to pass. About achieving flow in your presentation and in your code. So what is flow in this context? Flow is the state when you're coding, everything's chugging along, you're not hitting any nasty, annoying bugs. You're in the zone, right? Same thing with running, same thing with all these things. And your users, if you're an app developer, are feeling that too. So I'm going to take a quick sample of the crowd here. Who here actually develops mobile apps for a living? So I see a few hands being risen. OK, good. Not too many, so hopefully we'll teach you a few things. Who here is actually an Android dev, specifically? All right, again, 2 or 3 hands. Cool. So good, because I assume all the rest of you are super graphics gurus who will already know a lot about rendering and shading and all these things. So I'm not going to go into that too much. I'm going to go more about the UI side of things, right? So a bit of data, a bit of research first. I looked into it, and as you might know, there's a lot of studies that actually date back from the 90s that show that latencies in the order of like 100 milliseconds will have a fairly big impact on how your users use your apps or your software. What they found basically is that whenever a user perceives a delay, it changes the way they use the software significantly, right? What happens is that users, if they, for example, see a perceivable delay on clicking a button or scrolling something, they'll actually stop using that part of the interface, square. They'll avoid it. They'll go like water in a river, flow elsewhere, right? So it's very important to keep the response time high and the jank very low. So this is not a very scientific study. I found this on Stack Overflow specifically for cognitive visualization and cognitive perception. So the little study there is all about testing your own perception of lag. So the graph here is one person taking the test that you can find if you follow that QR code. And it basically just tries to throw different lags at you and see where exactly you're going to start reacting, right? So we see that that 100 millisecond is actually probably, if you look at it, that's the 50% point, right? So taking into account that users are probably going to guess wrong some of the time, like they're going to think they perceive the lag, that 100 millisecond spot is actually pretty much a sweet spot. But if you look at the 50 millisecond spot on the graph, then nobody, you'll never feel like you're perceiving lag. So there's still some gain to be done by going under that limit. Another study that's fairly well known, but I wanted to mention it here for one interesting fact. So the research at Google blog, a while back, I think it's a 2008 or 7 post, they made a study that's probably fairly famous where they introduced lag, A/B testing with their users on the search page, the main search page, right? So they introduced lags that would vary between 100 millisecond and 400 millisecond. And they would expose people to this for anything between a week to 5 weeks. And then they would stop. And they measured their usage pattern, how many times they use the search bar. So the thing, well, obviously people use it less, right? Yeah, the thing that was interesting is if I, as a user, is exposed to that 400 millisecond max, or even slightly lower, my usage pattern, my habits are going to change for at least 5 weeks. It's going to take 5 weeks before I go back to my original usage, which is huge if you think about it. The impact of lag is terrible at that point. You might be thinking, I'm comparing web, I'm comparing things that have nothing to do with the mobile experience. But I think that, and you're probably going to see my point, if you think about the touch interface, lag is even worse, right? This is the worst possible place to have lag. Why? Because, well, basically your brain is sending signals to your fingers touching the screen, and you're expecting instant feedback, right? I mean, your finger knows what's happening. If there's lag on screen, you can feel it, you can see it. If you've ever used some of those little drawing interfaces, whenever there's a laggy one, you don't even want to touch it. It's like impossible to draw, right? So when you're on mobile, you're restrained in power, you're restrained in capabilities compared to the desktop, but it's probably even more important to be responsive on these platforms. So that's why at some point Google introduced, well, I mean, I shouldn't say that's why they introduced this, but if you've ever worked on Gingerbread back in the bad old days, in my opinion, you probably know how bad it used to be on the phone, right? Like iOS had a major head start on responsiveness. The whole stack was very fluid, very responsive. You never had really trouble making a nice interface, even in the 3GS days. On Android, this has been a fairly recent development. There's a lot of hard work that's been going into that, and to make sure that this happens, you might have heard of something called Project Butter, of all sorts of improvement to the garbage collection stack on Java, and all these things. And we're at a pretty good spot right now. Like, performance is starting to get pretty decent. So they introduced material design last year for Lollipop, the new version. I wanted to touch upon a few of those design principles because I think they're pretty interesting as it regards to what a lot of the crowd here's skill set is, which is, for example, writing shaders or highly accelerated graphics code. So, first few things, a lot of the material spec has to do with design and styling. These are, interesting things, not specifically what we're looking at right now. In this case, we start seeing a bit the idea of the interaction. So that's more the colors, right? Like they are aiming for like color accents and palette tweaks and things like that. So that's interesting. Here, the colors are being sort of deduced from the actual picture of the album, the actual sort of overall shade of it. And, a lot of it is responsiveness as well. So we see it in the little animation there. Like the different, when you touch on one of those boxes, how the touch propagates. There's this sort of ink effect. So really, the whole design is around the idea that you're using paper and ink and you're touching these cards, these sort of physical things. It's, actually flat design, but still pretty skeuomorphic in a way, if you think about it, which, personally doesn't really bother me. The other thing that we see here is how animations have been tweaked to feel more natural, like more like cartoon physics a little bit. That's also a very interesting thing to look into. Now, a lot of that comes free with the platform, but not the most interesting bits. I'll show this as an example. Like, I talked with a few of the engineers at Google that worked on their own apps, on the Play app, the Play Store app, the Music app, and things like that. And what they all seem to be saying is that when it was time to port the apps from KitKat over to Lollipop, it was a lot of work for them. Why? Well, they went all out and they tried to be like exemplary in their way of using the concepts of material design. But the platform doesn't necessarily give you everything in hand. There are a lot of things you get for free. Like, you can animate a lot of these things. But if you look at it right here, there's a lot going on, right? Like, the album is zooming in. At the bottom, you see the title of the album popping up. The button pops up with a little shadow. At the very top, you might notice that the toolbar changes. All of this is very dynamic and very fluid, and this is this kind of thing that all developers should aspire to. Point being, it's nice to have new tools in your tool belt, in your toolkit, because that doesn't all come for free. So just a slide. So I'll make the slides available later, but for people watching, the sort of intro, a good intro to material design and how to integrate it in your app, that's the blog post on that. That's a very interesting one, so I definitely recommend you look that up. And yeah, so since there's not a whole lot of people in the audience that are super familiar with Android, maybe except for doing a demo, I know a few of you have done demos and have basically done them in pure C, which is fine. but some of the basics of the platform will be new to you. So I'll try to still go quickly over them because they're fairly well known. But I think they're still important for the rest of the talk. So here goes. So a few basics. Right. So getting started, I trust that does everyone here have good familiarity with Java? Like, show of hands again. Like, okay, so, all right, that's good. That's good. So usually when you know Java, you're on a good head start. The platform's not so hard to get into. You might lose a few things like dynamic recompilation, but besides that, you'll be in familiar grounds. All right, so the three big tools, Android Studio, which is based on IntelliJ. So if you're Java developers, you've probably heard or are using IntelliJ. If you're still using Eclipse, that's nice. The other tool that you could be using is something called the Genymotion emulator. You've probably heard of this, even if you're only familiar a little bit with the platform, but a lot of people will tell you the emulators are painful to use. And that's because they're emulators and not simulators that you get on the Mac, right? So this emulator is technically a bit of a simulator because it runs a tweaked VM, a tweaked image in a VirtualBox. But the advantage of this is that it's super fast and it's going to use your GPU on your device, on your computer. So you can do a lot of testing with that. You might even get more performance out of the emulator than you would a real device, which is something to watch out for, but I definitely recommend you check it out. And obviously it's fun to have a hardware device, so to do any kind of development. Okay, I'll go very quickly over these. So basic architecture for a lot of you, I know, are Linux champs. So yeah, it's based on Linux, if you didn't know. You can definitely do C code in there and sort of restrict yourself to that, and you can achieve pretty interesting results. But this is not what this talk is about. So application framework, applications on top, Dalvik, so you get a bit of a picture. Something I'll spend a few seconds more, though, on, just to give you, people who are new to the platform, a bit of an idea. The big concepts. So everything in Android kind of revolves originally around the activity. Now, the activity is a class that you implement. It's sort of your starting point. You usually implement many activities in your app. So in this case, we're looking at a typical sort of example app, which would be an agenda viewer. So the agenda view itself would be an activity. So you'd see a list, say, let's just imagine it's a list of items that are in your agenda that you are planning to do for over the next few days. You click on one of those, right? And then it would pop up a detail view. Now, the way Android works to navigate between activities, which you can think of as web pages, which keeps things kind of simple, is that it launches an intent on the system. The interesting part there is that you can specify and tweak some things, but if you launch an intent on the system, anybody can actually answer that intent. So it's a fun little way of doing things, like if you want to change your default email client or change even your dialer, well, maybe not your dialer, but you get the picture. You can decide that whenever somebody looks at a picture or you take a photo, for example, you can register a new app to be the official photo taker for your phone, and that will kick in. And you can also specify you just want your intents to launch internally into your own app. So if you have, like, say, 2 or 3 activities, they can talk to each other and pass the puck around. Then there's basic concepts like background services. So when you have code that's not actually living in a view, so it's basically a headless piece of code that, say, fetches things from the internet, that would typically be a service, fairly kind of simple concept. You have other things like broadcast receivers and data providers that you can implement so that others on the platform could call you to get data. So they do this for the basic tools so that you can access the user's contacts, for example, things like that. All right, so last slide about the basics, promised. This is the very, well, it's famous in my circles. We show this at every talk, almost. So that's the activity lifecycle. I've basically shown it here, not so much to go into the gory details, but more to expose you to the idea, because we're going to look at a GL surface view right after this. And the lifecycle is actually fairly important, whatever piece of code you do, even if you do write only in C++ or C, because, well, if the phone rings, or the user decides to quit your app, or something else happens on the phone, or even you take up too much memory and the system just decides that you're a bad citizen and wants to get you out of there, the lifecycle is very much a part of it. And it can happen that, you've set up a GL surface in there, user takes a call, doesn't come back to your demo or game or whatever for like a few hours, comes back or even a few minutes, And you don't have that context anymore. So you need to reinitialize the context of your app sometimes. And if you're not aware of this, you're going to get crashes. So that's why the diagram is up there, and that's what that slide there is actually not even pointing to the official docs, but it is pointing to a Stack Overflow, where they do, I think, a good job of explaining it more for people new to the platform. So you might want to check that out. So the GL surface view. I thought that was cute. It's a trap. It's not really a trap. It's not so bad. But there's a few little gotchas there that I wanted to mention, because I think the basics will be very familiar to most of you who are like into OpenGL day in, day out. But those little traps are really super annoying. You can lose hours on that. So I'll expose you to them, and hopefully you can avoid them. Right. So little hand-drawn diagram there. I like those. It's actually a lot faster than using Visio or whatever else you use. OmniGraffle. My God. All right, so big picture plan of how these things work, right? So you have your activity that I've been talking about. On Android, your activity usually will show something that's a layout.xml. So the layout, what is it? It's like the XML definition of your view. So in there, you define how you lay out your elements, and everything is a view in Android. So they're all little widgets that will be shown on a page. The layouts are views themselves without any actual, well, they would have a background, but they don't have any elements themselves. So, you know, you imagine the picture, you have a layout, and you put these items in the layouts, and you place them accordingly, right? So that layout.xml file is where everything is defined. When you want to use GL surface views, which will be rectangular views into a typical OpenGL pipeline output type thing, so you would define a tag in there. You would define your GL surface view in the layouts file, and that will be part of your actual layout. So, right. Here I have a bit of code so that you can see here the main activity. So the main points here to remember are the part where, if you look at the first method, which is onCreate, that's part of that lifecycle. This is the most simplified lifecycle you'd have. So when your activity starts, onCreate will be called. It'll do some basic initialization. Your activity is not up and visible yet. In our case, it's going to go and call its parent, obviously. But then after that, it's going to set its content view, which is the act of taking the XML file and assigning it to the activity. After that, keeping things simple, we have the GL surface view. And the GL surface view is found. This little command finds it in the layout, the instantiated layout. So, the first command will take that XML file, will read it, will parse it, will create all the elements underneath, and then you can grab the objects from that tree using that command. And then you get a pointer to your GL surface view, which in this case is only used to handle the life cycle. Right. So the reason you want to do these calls to pause and resume is because so the GL surface view, the thing to note is it has its own rendering thread, which is a fairly interesting thing, because you don't want it to be part of the rest of the rendering thread. So Android, as a lot of other UI-based systems, has like one main thread, one UI thread where all the rendering happens, where you want to be doing as little processing as possible, because anything you do in there will freeze the view and will be terrible. So it's not the place to call the web server for a 1 meg file, obviously. You want to do that asynchronously. And you also don't want your OpenGL rendering to be happening on that thread. You want it to be apart from it and piping at its own rate into that little window. Right? So to manage all of that lifecycle, those calls there on resume and on pause are there. So when on pause is called, your activity is basically being put aside, so it needs to free up that thread and doesn't need to perform anymore to calculate anything. And when it comes back, it wants to re-register to it, so that's why you call the on resume. All right, so another bunch of code, a little bit of code. There's not that much in the presentation, I promise, but I do figure you're the right audience to have a little bit of code. So the surface view, right? So that's the actual surface view that we've implemented. I've cut out a lot of the important bits, so you'll probably notice it doesn't make actually a whole lot of sense if you read it all through. But the big points I wanted you to see were the setup for the translucent surface. So one of the gotchas that I was mentioning earlier is that it's fairly arcane and badly documented when you want to configure your GL surface view to be transparent so that the other elements of the UI are showing underneath, which would be a very important piece of the puzzle if you want to have components that are GL rendered with standard UI components around them, right? So the important bits to know here are in the init method towards the middle. You'll have the call to the Z order on top, which is a bit of a hacky thing that's badly documented. So if ever you want to implement this, remember that a little bit. That's the particularly interesting one. And then, yeah, the config chooser sets up the color space, and then you also tell it that you want a pixel format that allows translucency. So, you know, fairly standardish stuff. And then the last part right there, so the processing, the graph you see, if you look at the graph on the right, you'll see that there's the renderer. So the renderer is assigned to your surface view, and this is the thing that's being called to do the actual rendering work, right? So we implement our own, typically. It has its own little methods for lifecycle. We'll see them in a second. And you assign it to your view, and you set the render mode. So here, the render mode can be, so that's interesting. You can decide to render every frame as fast as you can. Or if you have something a bit more static, where let's say that you're using this to generate a graph to show like a sort of analysis of data on the phone. So you can set it up so that it only renders whenever the data set has changed. So you can just render it when needed, basically. More of a static decoration type thing. All right, and our last frame of code. Right, so here, well, I mentioned the threading earlier. So this is where the thread is calling the renderer, basically. The things to note here, sorry, I have to scoot down to actually look at this. It's very tiny on my screen. Right, so on surface created, right. The reason to note that this method exists and you might want to use it in your own things is that when you lose the EGL context, so when I was talking earlier about the user getting a phone call and you're losing the GL context, when you come back from that call, that's where you want to be reinitializing it. It's the practical space. It's pretty well documented on the developer.google.com. So, or rather, that's developer.android.com. Sorry, I'm mixing websites up, but it doesn't matter. You use Google, you'll find it, right? Right, and then the last call on draw frame is where the actual work will happen. So, you'll clear your colors. So these calls I put there, again, because of the transparency tweaks that you need to do to make sure that it will render properly. So, you'll want to make sure to use a transparent clearing color. You can use something with a bit, well, if you want it opaque, you want it opaque. But if you can use like different levels of transparency of alpha channels. So. And yeah, and then the blending method are good if you want to make sure, obviously, that your triangles are going to be blended and all that. All right, so and then the rest, I believe that a lot of you will be a lot better better equipped than me to make really fancy shaders on top of that. So that's actually my intro to the next slide. I apologize in advance. All right, so this little video is just to show the concept. So you have the play button at the bottom, right? That's like a standard Android UI component. Triangle is in the GL window, and the GL window is actually taking up all that space that we see now with the little white triangles. And the background image is just something on the actual Android background layout. So, and it's probably absolutely not visible, but that little triangle had a bit of a grain in it. So I'll show potential use cases, so you'll get a bit of an idea of where things can go with this, because this is obviously not that interesting. So potential use cases for this idea. So there's two really big ones that I want to put up front. I feel are rather important. So rendering and manipulating data sets, so that can be a lot of fun. I can see how, I often don't really see a lot of nice visualization software on Android, and with the tablets now and the power of like the Shield, like a lot of people have been going on about it, and I'm one of them. So you might want to have more fancy visualization tools, not just a graph, but I don't know, 3D renderings that you can manipulate. So we didn't go over the details of it, but your GL surface view can also capture touches, right? And that's the whole point of having flow. When you can capture the touches straight there, and you feed them directly into your whole pipeline, and maybe perhaps you do physics simulation on the GPU as well, and all that while all that is going on. So you could see that your sort of loop is going to be a whole lot tighter. You're not going to have to go through layers and layers of view rendering on Android, and we'll touch on what it involves after that. but you'll see that it's such a tighter loop that there's probably a lot of potential to get a lot of speed out of it and a lot more interesting interactions. The other one that kind of struck me that I brought up, this is a very nice little shader I found. So it's very, very, very simple, right? But what I found was interesting is compared to, well, in relation to the material design spec, this little guy looks made out of construction paper. And it's very, like, there's a couple, if you look it up on ShaderToy using the URL, you'll see that there's like maybe 2 lines that will just add the grain and make it look that way, right? So I could just imagine something like that, a little puppet and a toy, like just in the app that you can play with, and it's super responsive. And you don't see a whole lot of apps that actually manage to you know, get into that range, all the while keeping, you know, staying an app. I mean by that, you know, games would typically take over the whole rendering and are going to be very much ports of the C code that you find on iOS. So there's a big opportunity to actually integrate better with the platform with these tools and the little tiny little tricks I showed earlier to get a bit more out of Android than you would typically if you were just doing a straight C port. Of course, if you're doing a game, it might not be a point, but if you have ideas for apps in mind or more little toys for people, or, you know, I have a 4-year-old daughter, so I know she'd kind of love to play with that kind of little thing. But I could also see some concepts, more serious ones, where you could sort of simulate ink. So the platform, the material design concept all being about ink and paper, if you could put some fluid dynamics in there, like some very interesting possibilities right there. All right, so we're going to get into a bit more of the standard platform. So there's a few things you'll probably want to know about when you start exploring Android that come with the platform. I'm not going to do for time, like there's a lot of super powerful tools for you know, gaming performance and all that you can get from NVIDIA. They have their own IDEs that run on Windows and all that. I'm touching more upon I'm starting to experiment with things, and it comes bundled with Android Studio, so it makes it easier to sort of start out with. So the hierarchy viewer, when you're in Android Studio, or IntelliJ if you use that, both pretty much the same, you'll have this little button there that allows you to launch the Android device monitoring tools. So these are tools to monitor memory usage, to monitor CPU usage, to monitor, you know, where your hot points are in your loops and all that. So the one we want to look at today is the hierarchy viewer specifically. So this one allows you, there's a couple places where you can get this kind of graph, but this one specifically is there to give you the graph of the view. So I was talking about the XML. You have to think of it, I guess the easiest explanation is to think of it like the DOM in a web page, right? So Android very much has a graph of interconnected items that are views, and some of those views are widgets, and some other of the views are layouts that just lay out the widgets. And you see such a typical graph right there on the screen. So use cases for the hierarchy viewer, say that you have 2 types of view, a simple view on the left, which only has like a simple string of text, and a slightly more complicated custom view on the right, which draws a little circle that shows you the percentage of the fraction and has like, you know, the fraction is laid out on 2 lines, and so slightly more complex. So if you run these 2 in the hierarchy viewer, there's a button in the hierarchy viewer that will measure the timings of your rendering of the tree. So what happens when you do that is that the system will, I'll talk about the caveat right after, but the system will go through the view tree, will render everything, will do all the layouts. So in Android, there's 3 passes. There's a measure pass to measure the size of all the relative components, because there's a lot of rules about, you know, I'm the button that's under this other button, and I will take the size of my parent. And if you start making all these relationships, you need to go through the tree to just basically size everything up and make sure the measures are right. Sometimes that requires a few passes when something has, you know, supersedes another one. So there's a few passes there. There's potentially a lot of lost time if you're using a very complex view. And the hierarchy viewer, when you measure those timings, if you see those little red dots on the different little graphs, so each chunk of the graph, each node in the graph represents a view item, and each color, each dot represents respectively the measure, layout, and draw times. So when you're in the green, it basically means that relative to the whole tree, you're good. You're not consuming a significantly more amount of time than any of the other ones. But if you look at the custom view on the right, one of those little nodes is red on the measure pass. So that basically says that this node in the tree is taking more time than all the others to measure. It doesn't necessarily mean that you have a bad behaving UI, but it does mean that if you want to optimize it and you know it's not reacting accordingly, according to your plans, that's where you should put your focus. So yeah, it's a bit more of a zoom on that little section. Now, the caveat here, and a lot of people might groan at this, is that you can only do it, it rasterizes on the CPU, basically. So it's not going to be super useful for GPU usage cases or OpenGL. But there is something for that. But first, we'll talk about how to improve performance in your views very quickly. So typical problems with the hierarchy viewer are this kind of tree. Like if you look at the overview on the right, you see that the tree is deeply nested. So deeply nested trees usually mean trouble on Android. So what you'll want to be doing is flatten that view, just as so. So, you know, fairly simple stuff. So that's usually the big #1 thing. If you fix that, you'll be good most of the time. So just thought I'd mention that. All right, so let's see. Yeah, okay, this is animating properly. So this is actually to show how to get away from the CPU-only measurements. There's one tool on the platform. When you turn on developer mode on the phone, it's fairly simple. You need to go click on the release version of the OS a few times, and then it will unlock developer mode if you haven't done it yet. It's a neat party trick for your granny. So once you unlock that mode, you see in the scrolly window in the middle, you can go turn on like OpenGL, I forget the exact name all the time, but it will basically turn on that little graph you see on the right. It's a bit subtle with the reds and yellows going on there. But the graph, the bar that you see at the top of the graph is actually the 60 frame per second mark, so 16 milliseconds, right? So whenever you go above that, you skip the frame. So, and that's going to take into account the proper device speed. So you're not only doing raster on the CPU or anything like that. So that you can know if you're skipping frames. That's the trick, basically. We can see that my little example is actually not super well behaved sometimes, but that's okay. You get the picture. There's also something else you can do, which is interesting. If you really want to go take a deeper dive, you can use this option instead in the GPU rendering menu. And so you see ADB shell dumpsys gfx info. So that's actually the command line. Once you turn that on, you go into your, so on Android, there's a command line tool called ADB, which allows you to connect to a device emulated or not. And basically you can get shell access into the Linux device, or you can launch commands that it will respond to. So if you only had command line tools, that's how you'd install your APKs. That's how you can get a lot of deeper debugging information that you typically wouldn't get from the IDE tools. If you're into that kind of thing, which I probably think a lot of you would be, I'd definitely check it out. There's ways of doing fun things with Android with ADB. But in this particular case, what you want to do is run the command that's going fast, which is the same command that's listed in the menu. So when you run that, it'll dump out to console out a ton of logs. What you can do then is pipe those into a file and just use your favorite Excel spreadsheet system to graph those out. So the little URL that's here is actually to a very, very good article that goes in much deeper depth, because I see I was planning for 30 minutes with a bit of Q&A, so I don't want to be too much over time. So anyway, that particular page, I recommend you go check out. It's a guy called Romain Guy, who's like a bit of a superstar in Android circles. And if you've done Java for a while, you might know the name as well. He used to work on a lot of the accelerated OpenGL stuff on Java. He has a blog called Curious Creatures, which this is linking to. So this specific post is a case study for an app called Falcon, which is a Twitter client from France. I think it was from France. That's very well regarded on mobile. And he was basically just going through the paces and seeing, okay, so where are they getting hits on frame rate? And he basically lists all the methods that you can go through to optimize your app and find out where the lags are and why you're skipping frames and all these things. And it's fairly interesting. And there's also a little method to just take that dump from the syslog I just showed a few minutes ago and put it in that nice little graph that we see here. So that's about it for me. I'm good on time. So thank you very much. It's been a pleasure talking to you guys. I'm obviously available for any questions on Android or any type of exploration or little hacks or whatever. I know somebody, I was talking with one of my travel buddies from Quebec about what can we do to get a better GNI toolchain, because they want to compile a bit better and start avoiding Eclipse. So we can look into that if you're interested, or any other questions, I'd be happy to oblige. Thank you very much.